All right, all right. Good afternoon, everyone. Good afternoon. Hope all is well. Everyone is doing all right. So let's see. Last class we talked about chapters 1 and 2 as far as definitions. I did tell you guys about definitions, right? Anybody can feel free to type in the chat and make sure
Yeah, we talked about it, and then that was
okay.
the homework.
Okay, just want to make sure I told you guys correctly and everything. Okay, so I know we did discuss a few things out of chapter 2. I want to at least do 3:1 today, just to get us started in chapter 3. Did anybody have any questions or concerns before we get rolling? Anybody? Anybody? All right. Somebody answer. All right, so let's look at 3.1, measures of central tendency. You don't have to write what's in the green over here. That was just a statement out of Math 155 that they needed. So you guys can hold true to just the black and the red. All right, so we're looking at measures of central tendency. First thing we're going to discuss is your mean, which is another word for average. In statistics, they don't use the word average normally. They use the word mean, but they're both the same thing. So you add up all your data values, divide by the number of data values, and that would be your mean. Trying to make sure my screen is shared properly. Okay. So just a simple example, if I have the data set of 1, 2, 3, 4, 5, I will add up 1, 2, 3, 4, 5 and divide by the number 5 because I have 5 data values. So that'd be 15 divided by 5, which would be 3. So the average or the mean of that data set would be 3. Yeah. If I scroll up and somebody's still copying, always, like I said before, make sure you let me know. The next one is the median. And when you think about the median, you can think about middle, as in the middle value. So to find your median, you list all your data values from least to greatest first. And don't forget that because a lot of people forget that first step. You want to list your data values from least to greatest. So if the number of data values is odd, you're going to just take the middle value because if you have an odd number of data values, then you will have a middle value. But if the number of data values is even, then you don't actually have a legit middle value. So what you'll do is you take the two middle values, add them together and divide by 2 so that you take the average of the two middle values. So we'll do that in a second. Just want to give you a chance to write down the steps. All right, so for the first example under the median, if I have the data set of 1, 2, 3, 4, 5, then my median will be the middle value, which is 3. And once again, that's because we have an odd number of data values, odd number of data values. If you have an odd number of data values, you can just choose the middle value. Now, if my data set is 1, 2, 3, 4, 5, 6, in other words, I have an even number of data values, then I would take the two middle values, which is 3 and 4, add them together and divide by 2. And that'll be 3.5 as my median. Notice 3.5 is still the middle. It's in the middle of my data set. It's in between 3 and 4. So that data value, your median, is always going to be in the middle every data set. All right, so in the green, the median separates the data set into halves. So, and once again, you don't need this over here because it's for 155. What's going on with my pen? All right. Next one is your mode. And you can think about most when you think about mode. So it's the data value that appears the most frequently. Wrote that a little better. Oh, pen not working now. So it's the data value that appears the most frequently. It is possible to not have a mode. It is possible to have more than one mode. Well, my pen not working. So if it's bimodal, that means it's two modes. Multimodal means you have more than two. Okay, there we go. Okay. All right, so if I have this data set right here, 127,896,752,976,51347. My mode would be 7 because 7 appears the most out of all the data values. All right, any questions? Any questions? All right. A few more things that they emphasize in this section. A summary of data is said to be resistant if outliers, very extreme values, your outliers are very extreme values. You're talking about very, very large or very, very small in comparison to your data set. So those are what outliers are. If outliers to the data set do not affect it. Okay, so I'll show you what that means in a second. All right, so if I have the data set 1, 2, 3, 4, 5, we already talked about that data set already. Your mean would be 3 and the median would be 3. Talked about that, add data values up, divide by 5, you get 3, and the median middle value is 3. Okay, now if I change the data set by making this 500, 500 would be considered an outlier in comparison to the regular data set. It's very, very extreme, very, very large. So when I find the mean, if I add those together, divide by 5, because I have 5 data values, I get 102. But the median actually would still be 3. That's the middle value. So this means that the median is resistant to outliers. And so that's what I mean by something being resistant to outliers. If when you put an outlier in a data set, it's not affected by it. So it is a good choice for a measure of the center if the data contains outliers. Talk about the median. Since it's not affected by outliers. All right, any questions, any questions? All right, so we'll do 3-2. 3-2 is short, and then we'll call it a day because you know, you have chapter 1 and chapter 2's content to take care of. But I know we only have 8 weeks, so I want to make sure we do cover something each class period. So 3.2 measures of dispersion. Dispersion is the degree to which the data is spread out or dispersed. All right. So the range is the first thing that they talk about in this section as far as calculation is concerned. So to find a range, you would take the largest data value and then subtract the smallest data value of your data set. So your range is the distance spanned by the entire data set. So if I have the data values of 1, 2, 3, 4, 5, I would take 5, subtract 1, and the range will be 4. All right. Standard deviation, it measures how far a data value is from the mean. Your variance is the standard deviation squared, and it's just another way to measure the spread of your data.
For the standard deviation, doesn't it come with a formula?
Mm-hmm.
I wasn't really sure.
Now, I wasn't gonna make y'all, you know, use a formula, but you know, if you really want to do it, you know, I can make sure that, you know, that happens.
Well, I do have a question though. So like the homework, will we have to like solve things with standard deviation, or is just more vocabulary?
Man, I'm about to get to all that, and you're not even gonna let me teach it. You just gonna. I'm just messing with you. Yeah, I'm about. Matter of fact, that's the next thing we're gonna talk about.
Okay, I was just making sure.
No, I'm not gonna leave y'all hanging like that. But yeah, so awesome segue into the next piece of what we're gonna talk about as far as the standard deviation and the variance. And so, like your classmate mentioned or noticed, I did not mention the actual formulas in order to calculate the standard deviation and variance. So basically, the reason being is because this book and this course doesn't really focus on the calculation or the formulation of the standard deviation and variance. And so what you can do is what I have here in the red is find an app, calculator, or website, something along those lines that will help you calculate the standard deviation or the variance. An example of that is easycalculation.com. And I'll go to a website and show you in a second. But yeah, and I'm not asking you to purchase anything. Anything you do could be for free. Like I said, easycalculation.com is free. There are a bunch of free apps out there as well. It's up to you what you want to use. You just want to make sure it's reliable. So when we do this data set, you'll see what I mean. But I'm pretty sure there's some things out here that won't work correctly, but you want to make sure that whatever you use, you are getting the right answer, you know, when you go throughout your homework so that by test time, you're not trying to figure it out. You know, you want to have something reliable by test time. All right, so once again, the emphasis of actually using the formula by hand is not your necessary priority. They even in the book, they'll say use technology or something along those lines. So that's what we'll do. And just give you guys a chance to write that down. See something, yeah, okay. So we have this data set right here that I'm gonna just throw into easycalculation.com and show you how we get the standard deviation and the variance. So here, now hold on one second, let me look at something. I'm gonna come back to it. Okay, empirical rule. Okay, notation right here. All right, got it. I know I put the notation somewhere. Okay, so this is our standard deviation. And this right here is our variance. All right, so let's go to website. I would just go to Google and do standard deviation. Easy calculation. And so that'll be the first one, easycalculation.com. So once again, I typed in, as far as Google is concerned, that's if you want to use easycalculation.com. Type in standard deviation, that's what you're trying to find, and then easy calculation. Once again, you don't have to use this website, but that's just one that I know will work. And then also make sure you pay attention to the directions of whatever you decide to use. It says enter, close that out. It won't close. Okay, trying to get rid of the advertisement. Enter your data values separated by comma. So we said 62, 88, 77, 68. Then hit calculate. And there goes our values. 11.3, 128.2. And I think this one, the one that we have, let me see if 11.3 squared. Yeah. So notice in the notes, I had 127.7. All you did was square 11.3. So this gives you a more accurate answer. So most definitely, you can use this one. But when you go to MathLab, also in MathLab, make sure you pay attention to the directions on if they want you to round to the nearest tenth, hundredth, or whatever the case may be, because it will mark it wrong if you round to the wrong place value. So, yeah. And like you're about to see next, notice you have standard deviation and variance here, but then you have population standard deviation and population variance. So in your definitions, you'll come across those two different terms, population versus sample. Population is the whole group of people or whole group of whatever it is you're dealing with. And a sample is just like you said, like you would think is a sample out of that population. So the sample is always going to be smaller than population as far as your data value is concerned. So whenever you have 4 values like we had here, more than likely that is your sample. So an easy example of that is the student body of TCC is the population. This class would be considered a sample of that student body. All right. Any questions on easycalculation.com or what I expect from you as far as calculation to standard deviation variance? Pretty good.
I did have a quick question. Going back to the notes, I noticed when you copied down the example for variance, the first one was 127.69 and then it was rounded to 127.7. Are we just rounding to the nearest 10th spot?
It depends on, and that's what I was saying, to make sure you pay attention to my math lab and what they ask for you in that specific problem.
Okay.
Because yeah, sometimes they'll say tenths, sometimes they'll say hundreds. And I probably did tenths because I probably copied it from the example in the book and that's what they did. But yeah, other than that, you want to pay attention to that specific problem that my math lab is asking of you, because they'll switch it up within different problems. Just make sure you're paying attention, because like sometimes they'll ask for the tenths in number 1, and then in number 2 they'll ask for the thousands place. You know what I mean? So
Yeah.
yeah, so just make sure you hold true to what they're asking of you.
All right. Thank you.
Not a problem. All right, so notation. So make sure we go to notation. I think this is the last thing of this section. Yeah. So notation. X is always going to represent your data value. Greek and let me stop right here. In statistics, you'll see a certain set of symbols that will represent your population calculations, and then a certain set of symbols that will represent your sample calculations. So when you see Greek letter mu, that represents your population mean. That's the average of your population. Then this is lowercase sigma right here. Greek letter sigma that represents the population standard deviation. And then lowercase sigma squared is the population variance. Now, capital sigma, if you know anything about the fraternities and stuff, they use the capital sigma. That represents summation. That means that you would add up your data values or add up your values. So we're not talking about capital sigma here. We're talking about lowercase that will represent your standard deviation and variance. Capital N is your population size. Now, when you talk about your sample, X bar, whenever you have a letter with the bar over it, is that letter bar. So that's X bar. Example right here, Y bar. I mean, if you had an A with a bar over it, that would be A bar. So, mathematics ran out of letters, so they had to start doing different things, to signify, different terms that they're dealing with. So X bar is going to be your sample mean. The lowercase s, just a regular lowercase s, is your sample standard deviation. S squared is your sample variance. And then lowercase n is your sample size. Capital N is your population size. Lowercase n is your sample size. All right. Any questions? Any questions? All right. Let me see. 3.2. Do I want to finish this off? Okay. So let's finish off 3.2. And then we'll be done for today. All right. So the next thing in 3.2 is your empirical rule. It says that approximately 68% of the data is within one standard deviation of the mean. And I'll show you a little diagram of what that means in a second. Approximately 95% of your data is within two standard deviations of the mean. And then approximately 99.7% of your data is within three standard deviations of the mean. Okay, so here's the diagram that goes along with that. And we'll, in the next example, we'll see how this applies to us. You have your mean that's in the middle. And then if you want to go one standard deviation out, that means if you add a standard deviation and subtract the standard deviation from the mean, that's going to be 68% of your data. So I don't know if you remember last class, I was talking about, notice this is normal distribution. Normal distribution, the bell-shaped curve. So remember I said in the middle is your mean, and then to the right of your mean is 50% of your data, to the left of your mean is 50% of your data. All together, that adds up to 100%. These percentages do not change, but the data values down bottom will change according to whatever your mean is and your standard deviation is. So I'll show you that in a second, but these percentages are your empirical rule. And so those percentages do not change. So notice you have 34%, 13.5, 2.35, and 0.15 on both sides. All right. And going out one standard deviation gives you 68% of data. Add 13.5 to both sides, that gives you 95% of your data. That's two standard deviations out. And then going out one more standard deviation gives you 99.7% of your data. All right. Scroll up. Anybody still holding on to it? All right, so let's apply this, and then that'll be it for today. So we have the mean IQ score of students enrolled at University A is 100, and the standard deviation is 16.1. Determine the percentage of students who have IQ scores within 3 standard deviations of mean according to the empirical rule. Let's see if I can get all of it in here. Yep. Determine the percentage of students who have scores between 67.8 and 132.2. Then determine the percentage of students who have scores above 132.2. Once again, I give you a chance to write that down. All right, so whenever dealing with a word problem, I always say that you should extract the given information first. So first thing we recognize is that our mean is 100 and our standard deviation is 16.1. And here I was just in the blue, I was just emphasizing that, you know, if it was a sample, then we would use X bar and S for, you know, symbolism, that's all. But it doesn't matter what you call it actually. You know, we're just looking at the percent, what the numbers are. Our mean is 100, standard deviation 16.1. All right, so going back to our diagram now, for the first one, we really don't need to calculate anything because according to the empirical rule, if you're going 3 standard deviations out, we already know that 99.7% of our data is within the empirical rule. But I want to go ahead and calculate these out and show you how these things work before we continue to move on. So I'm going to scroll back down, but I want to show you that we have our mean in the middle, and then we have these data values to the right and these data values to the left. So the way you get the data values to the right is that you add a standard deviation 3 times. So to get the first one, add a standard deviation. Second one, add another standard deviation. Third one, add a third standard deviation. Then to get the values on the left, you subtract 3 times from the mean. So that's what I did right here. Oh, okay. Well, let me erase that. So the first one, going 1 standard deviation out, all I did was take 100, add 16.1 to it. So that's 100, 16.1. Come on, guys. Yeah. Then add 16.1 to that gives me 132.2. And then add 16.1 to that, that's 148.3. So we took our mean, added a standard deviation, add a standard deviation, add a standard deviation a third time. And that gives me all 3 data values on the right. And then on the left, you subtract standard deviation 3 times. So subtract the 16.1 gives you 83.9. Subtract 16.1 again gives you 67.8. And then the last one, 51.7 when you subtract 16.1. a third time. So if we were to go according to our chart, this is how it would look. Our mean is in the middle with 100. Then we have 116.1, 132.2, 148.3. Then on the left, 83.9, 67.8, and then 51.7. Once again, just reemphasizing the fact that those percentages though didn't change. Those stay the same. It's just the numbers on the bottom that will change according to whatever your standard deviation is and your mean. All right. Any questions on what we've done so far before we go ahead and answer A, B, and C? All right. So like I mentioned earlier, when it comes to A, we didn't really have to do the chart. If you go back, just scrolling up, it says determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. And that was just this statement right here. 99.7% of your data is within 3 standard deviations of the mean. That's your empirical rule. So we didn't have to do any calculation for that. Just lean on the empirical rule. So that's why A is 99.7. So that's what we have there. So now the next one, determine the percentage of students who have scores between 67.8 and 132.2. So what you can do is find those values, 67.8, 132.2, and it said get the values between. So we take the percentages between and add them together. And that's what I did here. 13.5, 34, 34, and 13.5 gives me 95. So that's something you can always do and always play with when it comes to these numbers. If you want to know the percentage of students that you expect to score between a certain value, then you can just find that value, add data values in between it. Or if you want to know less than, you take the percentages that are less than that. It's just different ways you can play with these numbers. Or if you want to say, what's the chance that a student will score in between 68, 67.8 and 132.2, you got a 95% chance that a student will score, between those values. So it's another way of stating it or how you would look at it. And then C, last one, it says determine the percentage of students who have scored above 132.2. So 132.2 is right here. So you were talking about above, that would be to the right of that. So you're looking at these two percentages. That's 2.35 and 0.15. So it's 2.5%. Students you expect to score that high, or the 2.5% chance that a student will score that high. All right. Questions on anything that we've done?
You said yesterday that you'll put up a link with all the recorded classes, right?
Mm-hmm.
Okay.
Mm-hmm. What I try to normally do is wait for both lectures for that week and then do that after that versus doing it, after Tuesday and then have to come back, not Tuesday, Monday, do it after Monday, then have to come back Wednesday, just because I got so many classes and stuff. So if I have time, I'll do that today for you guys. If not, most definitely by tomorrow.
Okay, thank you.
Yep, not a problem.
Do you have the syllabus version of as you go like week by week for different dates and stuff, or you'll eventually just tell us about the dates?
All right, so what dates do you want to know about when you say dates?
So I make my own personal like schedule, so I know like, okay, this date I'm supposed to turn this test in, or this test supposed to come in, stuff like that.
Right. Now, so as far as dates go, you guys have a hard due date on December 17th, which is our last day of class. So you actually can work on stuff all the way up to that date and there is no penalty. Now, what you don't want to do is wait till December to start doing this work. Now, so if you want to the way you want to gauge yourself is that as these lectures go, you guys should be flowing with the lectures. So you don't want to be still working on chapters 2 stuff and we're in chapter 4. You know what I mean? Now I can always give you a soft due date of where I think you should be or where you should be, if you should be out of certain chapters according to where we are. But the safest way to look at it is that, you know, now that we're stepping into chapter 3, your goal should be to get into chapter 3 too. And so I really don't, for this class, and that it's worked in the past, is just leaving it with that hard due date at the end. It gives people the room to actually have life to happen, and then they don't have to ask me for an extension. Certain classes I can't afford that because certain things are just so stringent, like pre-calc 1. But yeah, if you need a guideline like that, then I guess you can email me and I can tell you like, okay, we are here. So yeah, you want to be out of those chapters by this type of date. But yeah.
Yeah, that would definitely help me. And like usually I like to work ahead, so I know, okay, am I too far or am I like just a little bit, you know?
Well, there's no such thing as too far as I'm concerned. Because if you're able to knock this stuff out and, and you know, you haven't hit a speed bump yet, you want to take advantage of those moments, because there may come a point in time where something may be a little harder and it may slow you up, and you don't want to hit that at the end when you could have hit that a little earlier and then had that cushion to be slowed up and not be an issue. You know what I mean? So I always say that if you can knock stuff out and you're comfortable with what's going on, go ahead and do that, especially since everything's open. And then, and like I said, the way you can gauge yourself is just where are we in the lecture? Because I'm not going to move any faster than where we are in the lecture. So today we did 3.2. And that would be where you would shoot to be at if you don't want to move ahead of me. You know, so.
Okay, thank you.
Yep, not a problem. And like I said, if you want, you know, extra like dates or something, you can always shoot me that email and I'll shoot you something. All right. Anything else? Anybody else? Anybody? Everybody good? Everybody straight? So don't forget, we are looking at I think I told you guys about Wednesday of next week for those definitions. Anybody want to confirm that? I don't know if I told you. I did. Okay.
Yeah, you
first.
said September 1st.
Okay, thank you, thank you. So yeah, so make sure you get those to me, because you know it's an easy grade, but I can't give you you know the points for it if you don't get that to me. So don't forget, you can shoot that to me any kind of way, whether it be taking a picture with your phone, scanning it, or doing it on a Word doc, and just shooting it to me through a Word document, whichever way. You know, if you want to type it up, that is up to you, and either way is fine. Let me see. Next class we will do 3, 4, and 3, 5. There is no 3, 3 that you're held responsible for. It's 3, 1, 3, 2, 3, 4, 3, 5. And then yeah, we'll continue to roll from there. Don't forget that this is an 8-week class, so you do need to make sure that you're on top of this homework and stuff. And you don't want to get, you know, put yourself in a compromising position. All right. Anything else before we close? All right. So you guys have a great weekend. Be safe. Before we do anything next class, I'll open up the floor for questions, see if you have any. Outside of that, we'll get back into chapter 3. All right. Take care.
Have a good day.
Have a
Thank
good
you.
week.
Same.
Thank you.
Take care. Thank you.